in linear law, we actually convert non-linear equations to linear form and linear equations to a non-linear form. Why do we do that? Because some situations in real world can be modeled using an equation. So for example, I have a simple pendulum that travels from one point to another point in a time of t seconds. So the distance that it covers can be denoted by L in centimeters, and the time that it takes to cover different distances can be denoted by T in seconds. So if I then plot a graph of this relationship, if I plot a graph of T against L, the points are going to lie on a curve. They are not going to lie in a straight line. And that curve might look something like this, for example. So I am plotting T against L. Now, if I want to find the equation of this curve, what can I do? Here is when linear law comes and plays its part. So if I am told that the rule connecting the variables T and L is believed to be T is equals to A into under root L. I've been told that this is the relationship. This might be the equation of the curve. So what should I do? I need to draw the graph of T against under root L now. Why? Because when I want to find the equation of the curve, I'm first going to plot it in the form of a straight line. And the form of a straight line is y is equals to mx plus c. Here you can see that T is playing the role of y, A is playing the role of m, and under root L is playing the role of x. There is no y-intercept here. So when I actually proceed to plot this graph, I'm going to get a straight line, T and under root L. And so now that confirms the belief that the rule connecting the variables T and L is T is equals to A into under root L. And this gradient, now the line that I've plotted, if I find the gradient of this line, so that gradient is going to give me A. So if I take any 2 points and I use them to find the gradient, y2 minus y1 upon x2 minus x1, I'll find the value of A. And suppose the value of A comes out to be 0.2. So the equation of my line becomes T is equals to 0.2 into under root L. So this is the equation of my curve, the original curve that I plotted. And in this example, what I did, I converted a non-linear graph to a linear graph. So whenever I need to convert a non-linear graph, any curve, any type of equation, into a linear equation or a linear curve, it must be in the form y is equals to mx plus c. Note how I'm using capital Y and capital X instead of the common small y and small x. That is because now this y is not just a simple normal y, and this x is not just the common x that we use in equations. This y could be any variable involving y or x or y and x. And same goes for this x. So either of these y or x could have been 1 upon x, xy, lgy. They could have been anything. That is why we use a capital Y and a capital X to denote them. Because when we're talking about nonlinear equations, so there could be logarithmic equations, there could be exponential equations, there could be quadratic, cubic, different types of curves. So that's why we cannot write them in the form y is equals to mx plus c. And in that case, then when we want to convert them to linear form, we take a different form of y and a different form of x, and then we bring non-linear equations to linear equations. Here, m remains the gradient and c remains the y-intercept. So let's have a look at an example. I have a nonlinear equation y is equals to ax plus b upon x, and I need to bring it into a linear form, that is y is equals to mx plus c. So I need to rearrange this equation such that it looks sort of like this, where capital Y and capital X can be any variables involving y and or x. Okay, so what am I to do first? I think I should multiply the whole equation by x. What does that give me? Xy is equals to ax square plus bx upon x simply gives me x. Simply gives me b. Now, if I have a look at this, so this becomes my capital Y, A becomes my gradient, x square becomes my capital X, and B becomes my intercept. So now if I plot variables xy against x square, now if I plot the graph of xy against x square, I'm going to get a straight line graph. The intercept of this graph is going to be B, and the gradient of this graph is going to be A. On the other hand, if I would have plotted the graph of the original equation, y is equal to ax plus b upon x, it would have been a non-linear curve. So now I brought it into linear form, and now when I plot capital Y against capital X, I am going to get a linear graph. Or another thing I could have done with this very same equation was that I could have divided this equation by x. So that would have become y upon x is equal to a plus b upon x square. So now if we write it in the form y is equal to mx plus c, p into 1 upon x square plus a. So this is in the linear form now. Capital Y becomes y upon x, m is b, capital X is 1 upon x square, and c is a. So that's very simple. In this manner, we can convert non-linear graphs to linear graphs. Let's have a look at another example. I have y is equals to a e to the power negative bx. And I want to bring it in the form y is equals to mx plus c, so that when I plot capital Y against capital X, I get a linear graph. Right now, if I plot this equation, I'm going to get a non-linear curve. I do not want a non-linear curve. I want a linear graph. So what if I multiply both sides by ln? Because when we have e, so it's best to use ln. So ln y is equals to, applying the law of logarithms, ln a plus ln e to the power negative bx. This can be rewritten as, it's ln e to the power negative bx. This is rewritten as negative bx ln e. Ln e is obviously 1. So this just becomes negative bx. So I can rewrite this as negative bx. And here I have it in the form y is equal to mx plus c. Ln y becomes capital Y. Then b is my gradient, negative b is my gradient, x is capital X, and ln a is the intercept. So this is another linear form. And in this manner, I convert non-linear equations to linear forms. Moving on, if they now tell me in a question that variables x and y are such that y is equals to a into b to the power x, they've given us a non-linear form, they've given us a non-linear curve, the equation of the curve that we need to bring in linear form. So, and then they say that variables x and y are such that y is equals to a into b to the power x, where a and b are constants. Now they tell you that the diagram shows LGY against x. So this is the diagram. It shows LGY plotted against x, and you have a straight line over here. And there are 2 points marked at the edges. One point is marked as 2, 5, and the other point is marked as 6, 13. And this is LGY against x. And they say that the graph passes through the points 2, 5, and 6, 13. They ask you to find the value of A and the value of B. So if we just quickly bring this linear graph into a table form, so I have x and I have LGY. When x is 2, so LGY is 5. When x is 6, so LGY is 13. That's all we'll be needing from this graph. And now, moving on to solving this and finding the value of A and B. First, we need to bring it in the form y is equals to mx plus c, because the graph that we're given is a linear graph. And obviously, it involves LGY somewhere, which is why they gave us that graph, right? So what if we multiply the whole equation by LG? So LGY is equals to LGA into b to the power x, applying the rules of logs. This becomes LGA plus LGB to the power x. LGY is equals to x LGB plus LGA, and this is in the form y is equals to mx plus c. LGY becomes capital Y, LGB becomes m, capital X remains x, and LGA becomes the y-intercept. So now you can see that when we plot capital Y against capital X, so we're actually plotting LGY against x. And this is exactly the graph that they gave us. So we have this equation. We have our equation in the form LGY is equals to x LGB plus LGA. This is our linear equation, and y is equals to a into b to the power x is our non-linear equation. Now, when we have this equation, we have capital Y and capital X, and we have values for capital Y and capital X as well. So when x is 2, so LGY is 5. So LGY is 5 and x is 2 into LGB plus LGA. And if we now let this remain at hold and we find the gradient using these 2 points, 2, 5 and 6, 13, the gradient comes out to be m is equals to 13 minus 5 upon 6 minus 2 is equals to 2. So LGB becomes 2. LGB is the gradient, as you can see from here. So now in this equation, if we put in LGB as 2, so 5 is equals to 2 into 2 plus LGA. So this becomes LGA is equals to 1, and hence A is 10 to the power 1, laws of logarithms, and A becomes 10. On the other hand, LGB is equals to 2. And again, if you apply the laws of logarithms, B comes out to be 100. So the value of A is 10 and the value of B is 100. This is our final answer. And in this manner, they can often give us equations of non-linear curves, non-linear graphs, and they can give us the graph of a linear equation or any 2 points from a linear equation. We first bring that non-linear equation to linear form, to the form y is equals to mx plus c, and then we use the coordinates to find the gradients, the x-intercept, the y-intercept, etc. Now, for example, let's have a look at another question. They give us some variables and they give us a table. Now, for example, they say they give us a table for x and for y. And now they say that by plotting a suitable straight line graph, show that x and y are related by the equation y is equals to k into x to the power n. And then they say that we need to find the value of k and the value of n. So we need to draw a suitable straight line graph. So how do we decide what a suitable straight line graph will be? We just have values for x and y, and they're not definitely going to give us a straight line graph, as we can see from the values. So when we want to bring this to the form y is equals to mx plus c, what can we do over here? We can again apply logs. So we'll take logs on both sides. LGY is equals to LG k into x to the power n. This becomes LGY is equals to n LGX plus LGK, and this is in the form y is equals to mx plus c. Capital Y is LGY, n is the gradient m, LGX is capital X, and the intercept is LGK. Now, using this, what can I do? I have LGY and LGX. So for this table, now I will make another table for LGY and for LGX. So if I first had x as 5, now I'm going to put in the value of LG5. And if I had y as 2593, so I'm going to put in the value of 2593, LG2593, and I'm going to plot these two values. And I will then definitely get a straight line graph because this is a linear form now. So when I plot capital Y against capital X or LGY against LGX as shown over here, I am going to get a straight line graph. And then the gradient of this graph and the intercept of this graph will give me the values of n and LGK. So my gradient is n and my intercept is LGK. And in this manner, I can also find the values of n and the value of k. This is mainly how we get the questions in linear law. And you just convert non-linear equations to linear equations or linear equations to non-linear ones, or you just find different values of constants if you're given enough information, as we just did right now. There are another type of questions they can also ask, and let's have a look at these questions then as well. Now they give us 3 equations. Y is equals to a b to the power x y is equals to ax to the power k and px plus qy is equals to xy. They give us three equations and they say that a, b, a, k, p, and q. These are all unknown constants. So if these are all unknown constants, then we can say that these three equations can be represented as a straight line. They all need to be expressed in the form y is equals to mx plus c, where x and y are each functions of x and or y, and m and c are constants. Now we need to make a table for them, and we need to tell them that for each equation, what is y, what is x, what is m, and what is c. So we obviously need to bring them in the form y is equals to mx plus c. So for the first equation, y is equals to ab to the power x. What can we do? How about we take log? So LGY is equals to LGAB to the power x. Whenever you have the right hand side in this form, AB to the power x, mn to the power z, or anything like that, so it's best to take logs. And when you have e involved or 10 involved, then you know you need to take the natural logarithm or you need to take LG. Now this becomes x LGB plus LGA is equals to LGY. So we already have it in the form y is equals to mx plus c. So we have to give the value of y, that's LGY, x, that is x, m, that is LGB, and c, that is LGA. Now moving on to the second equation, y is equals to ax to the power k. Again, it's in the same kind of form, so we can take log LGY is equals to LGA into k to the into x to the power k is equals to k LGX plus LGA. We have it in the correct form. Y is equals to mx plus c. Capital Y is LGY. The gradient is k. Capital X is LGX and c is LGA. So we give our values and then over to the equation, px plus qy is equals to xy is equals to mx plus c. So over here, this is a bit tricky and we need to have a look at it. We need to bring it in the form where y and x are functions of y or x and they cannot involve any other number. You could have, for example, 1 upon y because this does not involve any other number. It simply means y to the power negative 1. But you can't have 3 upon y because that means 3 into y to the power negative 1, which is wrong. We need to have y and x individually. We can have LGY, we can have LGX, but we cannot have any other type of number involved over here. So what do? We can bring the y terms together. So px is equals to xy minus qy. Then we take y common from here, x minus q is equals to, bring y to the side, dx upon y is equals to x minus q. Then if we leave y over here on the left hand side, because we need to have y alone on the left hand side to represent capital Y, this is actually 1 upon y into px is equals to x minus q. So if we rearrange it, it becomes 1 upon y is equals to x minus q divided by px. So this side of the equation is done. The left hand side is done. Capital Y is 1 upon y. What about mx plus c? So if we separate these two terms, so it becomes 1 upon y is equals to x upon px minus q upon px. So x upon px becomes 1 upon p simply, and write it as 1 upon p. 1 upon p minus q upon px. And if we rearrange these terms, so negative q upon p into 1 upon x plus 1 upon p. So capital Y is 1 upon y, m, the gradient is negative q upon p, capital X is 1 upon x, and c is 1 upon p. And in this manner, we have this as well in the form y is equals to mx plus c. So we're done.